Morning, fellas and ladies. Today's class, we are going to be focusing on the simple machine of a lever. Now, if you look at all these images here, you will notice that all of these are technically considered a lever. So a nutcracker, crowbar, hammer, using a screwdriver to open a paint can. In fact, even your arms are a type of lever. Now, if you remember from yesterday, we did talk about there being three types of levers, three classes of levers. And so today we're going to focus on levers in general and then focus a little more on each of those types. So, what exactly is a lever? A lever is going to be a rigid bar that is free to move around a fixed point. The fixed pivot point is called the fulcrum. Now, when you look at a lever, you have the fixed rigid bar, you have the fulcrum, and then you have the input arm and the output arm. The input arm is just going to be the distance between the input force and the fulcrum. The output arm is the distance between the output force and the fulcrum. So if we kind of use those terms that we saw on that last slide and look at this image. So let's focus on the image first. All right, so in this image, that plank, the board, that is your actual lever. Now, the thing that it is balancing on or pivoting on, that little triangle pyramid piece, that is your fulcrum. Now, the distance from the fulcrum to the 5 kilogram weight could be the input arm, and the distance from the fulcrum to the 100 kilogram weight would be the output arm. Now, we can use levers to figure out and calculate ideal mechanical advantage. To do that, we are just going to take, excuse me, we're going to be taking the output arm, or we're dividing the input arm by the output arm. So here we have an example that we can use to figure out the ideal mechanical advantage. So a woman uses a lever to lift a box like you see in this image. Now she pushes down on the lever 2 meters from the fulcrum. The box is 0.5 meters from the fulcrum. What is the ideal mechanical advantage of the fulcrum? So our input arm is where we are applying the force. So how far away are we? Well, she's 2 meters away. The box is 0.5 meters away, so that's our output. So we take input arm divided by output arm. So she's forcing down on the lever 2 meters away. The box is 0.5 meters away from the fulcrum. So we take 2 divided by 0.5 and we get an ideal mechanical advantage of 4. Alright, so that's a little bit about exactly what is a lever. Now we're going to look at the 3 different classes of lever. Okay, and this slide should look similar to what you saw yesterday. Yesterday we briefly mentioned the 3 different classes of levers. We're going to look at each one individually now. Sorry guys. But before we look at each individual one, let us do our joke of the day. So, what do you call a bear with no ears? B, because it has no ear. I'm so funny. All right, first class levers. So, first class levers are going to be your typical lever that you think about. So if you think about like a teeter-totter or you think about a seesaw, those are first class levers. In the first class lever, you have the fulcrum or the pivot point between the two different weights, between the two different loads, between the two different efforts. So you have the effort, which is the input, and you have the load, which is the output arm. So the fulcrum is in the middle. A seesaw is a good example of that. A crowbar would be an example of that. So if you're using a crowbar to pry something open, if you're using a hammer to pry a nail out, the hammer is acting like a first-class lever. This is your typical lever that you would think about. Now that takes us to our second-class lever. In the second-class lever, sorry guys, in the second-class lever, the weight that you're trying to lift is going to be between you and the fulcrum or the pivot point. Now, in a second class lever, the mechanical advantage is always greater than 1 because when you are using this, the weight is always closer to the pivot point than what you are. So because of that, mechanical advantage is always greater than 1 for a second class lever. Now, the best example of a second class lever is a wheelbarrow, which might seem a little weird that that's technically a lever, but it is. So if you look at this image that you see here that's moving, if you imagine that fulcrum being a wheel instead of that triangle piece, you might start to see the actual wheelbarrow aspect of this lever. Okay, so wheelbarrows are second class levers. Now I mentioned mechanical advantage is always greater than 1 for this type of lever. I think I forgot to mention that on the first one. So for first class levers, mechanical advantage can be about any number you can think of. It can be greater than 1, it can be less than 1. Um, Typically, when we use a first class lever, we try to make it so the mechanical advantage is greater than 1. So when you're using a crowbar, when you're using a hammer, typically the mechanical advantage is greater than 1. But in certain situations, it could be the opposite. It could be less than 1. All right, so let's go to our third class lever. So for a third class lever, the weight that you are trying to move is farther away from the fulcrum than the effort, the force that you're trying to use. So the effort, the force that you're trying to use to lift the weight is between that weight and the pivot point. Now, because it's always between the load or the weight and the fulcrum, the mechanical advantage is always less than 1. Now, your arm is a very good example of a third class lever. So, in a third class lever, your pivot point, if you're looking at your arm, is your shoulder. So, your arm pivots around your shoulder. Now, when you pick stuff up with your arm, you're picking it up with your hand, which is at the end of the lever of your arm. But when you lift it up, you move it, you're using the muscles that are in the middle of your arm. So your effort that you're using, the muscles, are always between the weight, which is in your hand, and your shoulder, which makes your arm a third class lever. Now, another third class lever would be like grilling tongs. So if any of you guys have done any grilling in the couple of nice days we've had since we've been on quarantine, you may have used tongs to pick up the meat. Now, when you do that, the tongs are connected at the very back end, which is the pivot point, the fulcrum. And then the weight, the meat, is always going to be picked up at the very end, and you grab it in the middle. So it acts like a third class lever. So, anyways, this is our lesson on specifically about levers or levers. Go ahead and do the assignment. If you have any questions, please shoot me an email.